Welcome to our audience with Bluwan. This conversation is part of a Sanyal report looking at the different small cell backhaul solutions that are available out there today and the evolution of mobile operators' requirements for small cell backhaul. My name is Hiley. I'm here today on behalf of Sanyal, and I'm joined by Shayan Sanyal, Chief Commercial Officer at Bluwan, which is a company that's taking point-to-multipoint solutions to new spectrum bands and new levels of performance. Many operators are looking at point-to-multipoint wireless backhaul solutions as part of their small cell backhaul strategy, so it's great to have Bluwan with us here today. Shayan, could you give us an overview of your company and the products that you're targeting the small cell backhaul market with?
Thank you, Lance. Yeah, of course. First of all, a little bit about Bluwan. Bluwan was actually spun off from Thales Communications, a French aerospace and defense company, in 2005. And from there on, we developed a disruptive technology called fiber through the air, which is really specifically targeted for the telecoms industry. And fiber through the air technology leverages four basic components in our architecture. The first one is a multi-gigabit wireless point-to-multipoint architecture, which enables operators to efficiently allocate bandwidth and reduce costs while providing very significant network coverage and flexibility. The use of very wideband frequencies in the 42 gig spectrum, which enable ultra-high bandwidth applications. A unique multiplexing technology, which allows operators to carry different data flows through multiple channels within our radios. And a self-optimizing network layer, which really dynamically optimizes all of what I've just spoken about based on real-time network data. And specifically for small cell backhaul and multi-layered heterogeneous network backhaul, we've developed a backhaul solution called Link Fusion. And Link Fusion is a millimeter wave point-to-multipoint wireless backhaul solution, specifically targeted for small cell and HetNet backhaul, and delivering ultra-high capacity over the last mile. One of the key differentiators is our ability to provide up to 10 gigabits per second from a single transmission hub, and allowing operators to easily address what we call the bandwidth density requirement, delivering peak point-to-point link performance to endpoints using a point-to-multipoint architecture.
Well, that's great. It sounds like you've gone a long way to addressing a lot of the different topics and requirements that operators are saying are important to them when they're selecting small cell backhaul solutions. Would you say that there's a specific positioning for your product? Is it a not spot solution, or is it a hot spot solution? Are you targeting rural, metro, line of sight challenged areas, or non-line of sight challenged areas? What market segment are you really trying to address with it?
It's actually really simple. We're really focused on where the bandwidth demand is actually exploding, where the bandwidth density requirement is increasing geometrically, and where we're seeing that happen most of all is in dense urban metropolitan areas. But not just any sort of metropolitan area or any service provider operating in that environment, but operators that are specifically looking at expanding the network capacity through the rollout of either 3G small cells or metro cells initially, or even potentially 4G metro cells, or even carriers that are, or mobile network operators that are starting to desaturate their existing networks by using carrier Wi-Fi type solutions. And you know, potentially even rolling out 4G macro sites with sort of peak requirements above 200 megabits per second. So really where we're focusing on is those kind of heterogeneous environments, and where operators are specifically rolling out those types of edge technologies, and where the forecasted capacity requirement in those areas is likely to be over a gigabit per square kilometer over the next 12 to 24 months.
Well, it really sounds like you're trying to address the performance, the levels of performance that a lot of operators are concerned about in terms of being able to deliver to not just their small cells, but also to their macro cell network as well. If you've got that level of performance, you must be using a lot of radio spectrum, and I heard you mention the 40 gigahertz band earlier. Could you tell us a little bit about the spectrum that you're using and what it costs?
Yeah, of course. So, as you correctly pointed out, we are extremely focused on a particular spectrum band, which is part of the Q band. And I think a lot of operators will have heard of V band or E band type spectrum in the millimeter wave. A lesser known spectrum band is actually the Q band, and part of that Q band is the 40 gig spectrum, which is actually a spectrum block that's ETSI normalized and SEPT harmonized, which operates between the 40.5 gigahertz and the 43.5 gigahertz. So in effect, it provides about 3 gigahertz of spectrum to operators, which has, by and large, been left untapped and unused. So we could actually call it virgin spectrum. The advantage of having virgin spectrum at your disposal is that you can start looking at contiguous block allocation of that spectrum. And when you have contiguous block allocation of spectrum, you're able to actually generate a hell of a lot more capacity using advanced radio equipment than if you were operating in a single channel, say a 56 megahertz channel or a 28 megahertz channel. So as a result of that, when we saw this spectrum and identified its properties, compared it to other spectrums that were probably higher in terms of the 60, 70, and 80 gig spectrum bands, and compared it to other sort of point-to-multipoint spectrums in the sort of 28, 10.5, or 32 gig bands, we saw that this was an ideal opportunity to build a multi-gigabit radio system that could leverage those contiguous spectrum blocks to generate multi-gigabit sectors. So really kind of addressing some of the challenges that operators were facing with traditional point-to-multipoint microwave in the recent sort of last 12 months, where they feel as though the future-proofness of those solutions for their mobile backhaul and small cell requirements may not be sufficient, maybe tactically sufficient in the next 12 months, but going beyond that may require revisiting.
Well, that's good. I mean, it certainly sounds like you've got a frequency or a spectrum competitive advantage. I mean, if there's 3 gigahertz, I think you said, of virgin spectrum available out there, how are you leveraging that with a technology advantage? I mean, what makes your solution better than others in the line of sight multi-point backhaul category?
Well, I guess the first thing is, excuse me, the first thing would be the ultra-wideband chipsets that we've developed, designed and developed, which are essentially 1 gigahertz wide radio chipsets. We've designed and developed the MMICs, all of the sort of power amplifiers and the synthesizers are protected and patented by us, and allows us to leverage that contiguous spectrum, understanding that not every operator is going to get a 1 gig block allocation. They may get 250, 500, 750, but regardless, our radio is wide enough to transmit and consume whatever spectrum would be available to the mobile network operator. The second thing that we did was actually develop an advanced multiplexing technology that allows us to actually take standard sort of 40 megahertz channels and essentially multiplex those, bond these channels together, fuse them together to then feed our 1 gigahertz wide radio. So it's an IDU component that stacks multiple modems together and channel bonds them to create enough capacity that goes up to the air interface. The third thing that we did was actually develop a software and network optimization layer that allows operators to dynamically allocate traffic and throughput to endpoints based on need. This is different from statistical multiplexing, which kind of analyzes peak versus mean. It's got nothing to do with that. It's more about looking at the type of demand that's at an endpoint, whether the download requirements are at 80% versus the upload, which is typically what we're seeing as an asymmetric use of demand at the endpoint. In certain cases, that's actually reversed, where the upstream requirement is actually higher than the lower the downstream requirement. So this is part of the reason why we developed a TDD-based system, because we wanted to efficiently use that spectrum at the endpoint and allow operators to adjust the bandwidth they were providing and the shape of that bandwidth based on the actual UE demand. Beyond that, because of the significant amount of capacity that we can provide to an endpoint, we can actually enable applications such as backhaul infrastructure sharing. So because we can deliver up to 240 megabits per second peak capacity to an endpoint, some of that may not be consumed by a single operator, especially in the context of small cells and the heavy sort of council and administrative requirements in terms of site acquisition that we're seeing in the industry today, one of the biggest challenges for small cell deployments. We know that there is a trend where operators are going to have to collaborate and potentially have to share the backhaul infrastructure before putting in their actual small cell unit. So our system is able to essentially provide a multidimensional traffic profile to each of these operators. So say you have two operators sharing a lamppost. Operator 1 can have a downstream of 100 megabits, an upstream of 100 megabits, so a very symmetrical pattern. But another operator sharing that backhaul could have another sort of more like download-centric configuration. Each of them have their own QoS profiles. Each of them can manage their policies individually, so they have complete freedom of movement in terms of customizing and tailoring their offer, right, to their users, but the infrastructure is actually shared. And that can help a number of use cases, like providing managed service backhaul for small cells, as something that MLL Telecom, for example, in the UK, is trying to do.
That's fascinating. So it sounds as though the product is not only adaptive and dynamic in some respects in terms of how it allows the operator to manage traffic, but it's also very flexible in how it can be configured, I guess, in terms of where it's being deployed. And when it comes to deployment scenarios, I mean, what is this product like to install? How long does it take? What's involved in terms of skill sets? And and are there any other installation parameters or aids that you can put into the product to make it easier to install?
So I think we're going to break this down into a couple of components. One is going to be physical. The other one is going to be more sort of OAM related, if you know what I mean. So from a physical perspective, it's a point-to-multipoint system. So you're talking about an access point, what's typically called in the industry an access point, where you have a sector, a 90-degree sector. The typical range is around 2 kilometers. That sector then provides 2.4 gigabits per second of capacity. Once that's set up, and that typically takes a bit less than a day to set up, once you've got that up and running, really you've got a planning perspective, right? So where do I actually get line of sight to the places that I want to provide bandwidth to? Now, we're cognizant of the fact that, line of sight can be a challenge in a dense urban environment. We have a lot of clutter, we have a lot of street furniture. So, having taken that into account, we also developed what we call a relay node infrastructure, which is essentially as you deploy terminals, some terminals can then, be leveraged to catapult off that to then light up a shadowed area, right? And so essentially you got a 90-degree sector, but then within that sector you may have actual relay nodes that are lighting up masked areas that you don't have access to from direct line of sight to your aggregation node, right? So that's one point in terms of the planning. The other thing is we've developed in our radios they're integrated antennas, so they're very small form factor. Our actual access point radio weighs 3 kilos approximately. It's an all-out. It's a split mount configuration where the indoor unit is actually inside the data center or the cabinet, but then the radio component is a 3 kilo, the size of a shoebox, I would say, in terms of the form factor, and then once you've got that in place, the actual network terminating equipment or the terminal equipment is actually available in multiple configurations depending on the usage that the client needs to make in his network. For example, if you're providing capacity to a relay site, right, you may want to deliver 240 megabits of peak traffic to that site and then drop off maybe 120 megabits per second on that site and relay another 120 down a street canyon, for example. And that street canyon would then have 120 megabits per second of backhaul capacity that could be shared between 4 to 5 sites using what we call our Metro NTE. And our Metro NTE is a 15 by 15 small form factor PoE powered device, and essentially, plugs straight into the lamppost or the street furniture, and then because of the beam width in the NTE, we have a 6-degree sort of beam width within that antenna. So it's actually, you don't need that exact line of sight. You have some flexibility in terms of getting the signal and getting the loss activated, right? So it's not like the point-to-point millimeter wave vendors that tout 1-degree pencil beam width type of advantages. We actually view that as a disadvantage because it takes time to align. It takes time to make sure that the street furniture is actually robust enough that you won't waver your signal. We've built in that yield, okay? So that's the physical properties of the solution that make it easier to install. Typically, an NTE takes less than 3 hours, more likely 20 to 30 minutes, but maybe the first one takes a bit longer, and after that you've got, you understand where your hub is, and the alignment becomes a lot easier. From an OEM perspective, once a technician, and I'm underscoring the fact that it's a technician, not an engineer, right? And it could be a local council technician that's managing the lamppost as opposed to an advanced resource that has a telecoms engineering degree. That's not what we're trying to target as our end user for that device. We've built in OEM features that allow auto burn-in, auto configuration, make sure that all the configuration settings are actually set up in our NMS. So really, once you've got the alignment set up, there's a session that opens up back to the network controller, and that actually provides all the configuration settings, so the technician can actually move on to the next lamppost or the next site, and then gets notified as and when things progress.
Well, that's good. So it sounds as though the solution from an installation point of view has got one eye on ease and flexibility and the types of people that you have to use to install it, and that's going to contribute a lot towards what it costs to install it. In what other areas does your product contribute to helping the tight cost budgets that mobile operators have when they're planning their small cell networks?
Actually that's one of the most important questions. Is that people talk about total cost of ownership. It's interesting because when we were speaking at Mobile World Congress earlier this year on the small cells session, we actually had a debate on whether we should be talking about total cost of ownership or maximizing network value. Let's face it, operators that are rolling out small cells are not reducing their TCO. Right? When you're talking about a densification of 6 to 10 times your macro sites, you can't be legitimately talking about reducing cost. You are increasing cost, regardless. And what you're trying to do as an operator is maximize as much as possible the efficiency of that investment and maximize the value that you're creating by rolling out and investing in these types of topologies. So I want to set the record straight on that. That doesn't mean that you shouldn't be looking at cost, but it's a very value-driven, total, 5-year business case, and making sure that that works. If that doesn't stack up, focusing just on CapEx alone isn't going to solve the equation. CapEx is a very important point, but OpEx is one of the Achilles heels of the successful execution of small cell network topologies. At least that's what we believe, and that's what most of our customers have been telling us. So going to that point, there's the traditional point-to-multipoint advantages, and I'm sure that other vendors have been talking about those advantages. Just to quickly sum them up, when you're talking about a PMP architecture versus a point-to-point architecture, well, you're actually talking about nearly half of your equipment having to be reduced, right? You don't have nearly as much equipment in PMP than you have in point-to-point. That has a ripple effect in your business case, obviously, because that means you end up paying less on site rental costs, especially for aggregation nodes or macro sites where you need to actually provide the backhaul from. And typically those are quite expensive and can go up to 1,500 to 2,000 pounds a year per 30 centimeter dish in the UK, $800 per dish or per antenna per month in Egypt. Very expensive cost. The second thing is, the second ripple effect is around the actual power requirements to power all these equipments. When you have half the equipment, you have a lower power overhead. Finally, in terms of that ripple effect, you're talking about the deployment, installation, and commissioning of this network. And with point-to-point, the problem that you typically face, whether it's in its millimeter wave flavor or not, it doesn't matter. Point-to-point is always going to require a dual-ended installation. That means two teams lining up the link, and the planning requirement that goes into developing a point-to-point small cell network is often not talked about. The fact that you can daisy chain is, commendable, but the fact that you actually have to daisy chain and mesh your network from a planning overhead perspective requires so much more effort from an operator perspective. And operators are not trying to beef up their network architects right now. They're trying to actually outsource as much of that as possible. And really, by deploying these types of architectures, you're creating a major planning overhead in terms of actually effectively planning a point-to-point tree branch daisy chain network. PMP is absolutely the opposite, right? You set up your sector, and it's fairly simple hub-spoke architecture. It's a single-ended installation, less people on the ground, less overheads. So that's the PMP sort of traditional angle. There's a second angle when it comes specifically to link fusion, Bluwan system. The spectrum allocation is one that needs to be looked at very closely. For example, in the UK, operators have had a very, very high cost advantage, a low cost investment in wide area licensing. For example, UK Broadband / PCCW in the UK was able to get 2 gigahertz of spectrum for nearly £120,000 for a 15-year nationwide license, non-revocable. Right? That basically makes it such that the spectrum actually has no capex impact on your business case whatsoever. You basically know that you're going to amortize that within a few months of deploying the solution. So obviously this is one example. We're working with multiple regulators around the world to replicate the Ofcom model in various degrees of success. There are some countries that are not as progressive, shall we say, as Ofcom, and I don't believe I would ever have said that, but yes, Ofcom is progressive when it comes to that kind of spectrum. But there are other countries that are looking at wide area licensing. So the final thing around the total cost of ownership or the maximizing network value is the actual business case to the operator. And we've done a number of studies with our trial customers, and this is one of the reasons why we're trialing our technology with Tier 1s and Tier 2s around the world, is we were able to demonstrate that from a cost per megabit perspective, purely on an OpEx side, we can provide a 60% saving compared to existing solutions that they have in their network today. So for an operator in the UAE, that can amount to nearly $100 million worth of savings over a 5-year business case across their high-density urban environments. And that's a significant cost saving when you look at it from a purely business case perspective. And I think that's one of the key things that we're focusing on.
No, that's great, Shayan, and thank you very much. Your insight and observations are going to be a great contribution to this report on small cell backhaul. Just to remind everyone, the report aims to provide an overview of the different small cell backhaul solutions available, and like this interview, there will be in-depth interviews with all the leading vendors who have participated in the report. The report can be downloaded from the Sensafili website, sensafiliconsulting.com. So with that, I'd like to thank you very much, Shayan, for your comments and your time today, and wish you and Bluwan the best of luck with your trials and deployments to come.
Thank you very much, Lance.